This is the screencast for section 9.45b, example 4. How about if we look at the summing of a telescoping series? Now, we call this a telescope for a reason, and I'll show it to you more later as we expand this series. Well, I've got the sum of this series 1 over n times n plus 1, which gives me a great opportunity to find two terms, split this into two terms using partial fractions. So I get 1 over n, and then that was a negative 1, so plus negative 1 over n plus 1. So here we go. There's my partial fraction. Now let's look at just partial sums. So how about the sum of just the first term here? So that would be 1 over, if n equals 1, 1 over 1 minus 1 over now 2. So there's just our first partial sum, which is 1/2. Our second partial sum, that middle term, negative 1/2 plus 1/2, those cancel out. So I really am just left with 1 minus 1/3. And then the third partial sum, I can see this concept of telescoping. Each new term in the partial sum has a part that cancels out with the previous, so it's kind of like a telescoping mathematically concept. So I got 1 minus 1/4, that first term minus the last term. So overall, if I were going to look at the nth partial sum, all these middle terms cancel out. So all I'm left with is 1 minus 1 over n, which is my first term and my last term. Again, this telescoping concept. It's really only the first part and the end part that matter. So now I can say that this sum of my series, which I could call just plain S, and I could say that that's also the limit as n approaches infinity of the partial sums, is going to be the limit as n approaches infinity of this S sub n, which is 1 minus 1 over n. Well, as n approaches infinity, that's 1 minus 0, so that's just 1. So the sum of this infinitely long series turns out to be just 1. So now in the Now Try problem number 48, I see a situation where, again, I'm going to have this telescoping series. A hint towards that is you have these factors in the denominator, so I'm going to use partial fractions and set that up as a series of two separate terms, one subtracting the other, which is going to create that telescoping pattern like we talked about before. The first term in the next term of the series is going to cancel out with the previous. You saw it in the example, right? So the nth partial sum is then going to be this first piece of the first term, so 1 over 4 times 1 minus 3, and then the last piece of the nth term, so minus 1 over 4n plus 1. Remember, all those middle pieces are going to cancel out. That's the whole concept behind that telescoping series. So simplify, and basically I can say that the limit of the nth partial sum is then going to be 1 minus 0, because as n approaches infinity, this second term here is going to approach 0, which is then 1. So we could write our answer like this, S representing the sum. You could write it as the sum with your sigma n equals 1 to infinity. There's a variety of ways you can write this. This is how I chose to write it.